Hey everyone, this is 3.7. For unit 3.7, we are graphing linear inequalities. Remember, inequality means greater than, less than, greater than or equal to, or less than or equal to, rather than zero. So that's what inequalities means. We are also graphing the intersections or unions of two linear inequalities. So, oops. Example 7, graph the intersection of x is less than or equal to 2 and y is greater than or equal to x plus 1. They will, where those two solutions cross, we will just be marking on the graph. That's what that means. So just like in the previous lesson, we were graphing linear equations. Now we're graphing linear inequalities. So you already have a lot of algebra skills to apply to this work. You can solve equations for a variable, right? If I said x plus 6 is 10, is equal to 10, you can tell me what x is, right? X is 4. You could put that on a number line. By just marking 1 point on the number line, right? X is 4. It's only 4. It's not 3. It's not 5. It doesn't move. It doesn't encompass infinite points, right? X is 4. So if I changed it to x plus 6 is greater than or equal to 10, my answer would then change to x is greater than or equal to 4, right? To graph this one, it looks a little bit different, right? We make the bracket because it includes the 4. We make the bracket and we draw a line going forever, infinity to the right, right? That's what that looks like. And if we had x plus 6 is greater than 10, that becomes x is greater than 4, which means it does not include 4 on the number line. It's only the numbers larger than 4, right? So that we showed with parentheses instead of a bracket, and that same arrow going forward forever, right? There is infinite number. Sorry, there is an infinite amount of numbers that are greater than 4, right? So the solution of, which is what we're graphing, the solution of an inequality is a set of infinite number of solutions, right? Here, 4 is not in the solution set. Here, 4 is in the solution set, right? This is any value greater than 4, including 4. This is any value greater than 4, not including 4, right? So this is not including 4, and this one is including 4 in our solution set. Either way, the solution set is an infinite number, right? So that was the prior knowledge, sorry. That was our prior knowledge of equations and inequalities. Now we can ask ourselves, what about inequalities on the coordinate plane? Because this is on the number line, right? These are inequalities on the number line. And the difference between the number line and the coordinate plane is the coordinate plane has the x number line going this way, right? And then it has the y number line going this way. So that's positive and that's negative. All right, so we know, for example, we know that, trying to decide where to write. Yeah, it'll work better down here. Okay, so I'm going to make two coordinate planes. Okay. We know what the line y equals x or y equals negative x, right? Each point on that line is a solution of the equation. So if this was the equation y equals x, yeah, that means it goes through the origin and then the slope is up 1 over 1, up 1 over 1. So we know that that is the graph of the line. It's a solid line, and every single point on that line is a solution to y equals x, because this point would be 0, 0, 0 on the x, 0 on the y. So that means 0 is 0, that is true, right? This one is the point 2, 2, because we just went up 1 over 1, up 1 over 1. 2 is 2. That's true, okay? So each point on the line is a solution to that equation. We know that because the first number of the point is the x, the second number is the y, and we put those into the xy of the equation, and the equation is still true. If this was an inequality instead of an equation, so if this became, right now it's y equals x, right? If this became y equals greater than or equal to x, it's the same line. We start at 0, 0, up 1 over 1, up 1 over 1. It's the same line, and all of those points are still true, right? If this is 4, 4, and I substitute in 4 for x and 4 for y, 4 is still greater than or equal to 4. So all the points on the line are still true for that. But we have to shade everything above the line. Y is greater than or equal to x. This is positive x, positive y and negative y. Positive x, negative x, just like the number line, right? So everything above the line, or everything toward positive y, gets shaded because everything above this line is true for this inequality. Every point on the line and every point above the line will make this inequality true. So let's just pick a point. I'll say that this point is -6 on the x, 0 on the y, right? We all agree that that's what that point is. So if I plug it in to y is greater than or equal to x, what I have is 0 on the y is greater than or equal to -6. Is that true? That is true. Okay. If I pick a point over here, 6, 0. So now we're on positive x. 0 is greater than or equal to 6. It's not true. So we're shading what is true. That is the difference between graphing just an equation with an equal sign and graphing an inequality. You're also telling me, or telling, with your shading, you're telling us that everything else is also a solution, okay? If it was y is less than or equal to x? Same line. But now I'm shading below. So this is less than, right? This is the y-axis. This is toward positive y. This is towards negative y, right? It's less than. So I want to shade towards negative y. And I can just pick a random point in that shaded region, like that would be 5x negative 5y maybe, right? So y is negative 5, x is 5. Is that true? Negative 5 is less than or equal to 5. That is true, okay? So that's what we're doing. That's the difference between just the line, and the inequality, greater than or equal to, less than or equal to, okay? So this says it's written in the form ax plus by is less than c, or it could be greater than or equal to, less than or equal to, okay? These are real numbers. They are not both 0, and it could use any of the 4 symbols. An ordered pair, which is this, a point, is a solution of the inequality in x and y if replacing the variables x and y with the coordinates of the ordered pair results in a true statement, right? So we said 4 greater than or equal to 4 is a true statement, but we said 0 greater than or equal to negative 6. Oh, sorry. 0 greater than or equal to 6 is not a true statement, right? So it's not a solution. That's why it's not shaded. It's not part of the shaded region. All right. Why do we need to shade? So all points on the line are solutions. All points in the shaded region are solutions as well. Okay. What if we are shading, it's not equal to, right? It's only greater than. So we'll keep using that same y and x, but now I'm going to say y is greater than x. There's no equal to, okay? Y is greater than x. It's the same line, but I'm going to make the line a dashed line. So when it was on the number line, we had parentheses or we had brackets, right? Here we have dashed lines and solid lines, okay? It's still y is greater than x. So we're still going to shade everything toward positive y. And all of this will be in the solution set. Like maybe this is 0, 2. Okay. If this is 0, 2, x is 0, y is 2. That is true. And then down here we'll go, this is 0, negative 2. X is 0, y is negative 2. So that's not true, right? It's not part of the solution set. What about right on the line? 0, 0. 0, 0 is right on the line. 0 is greater than 0? Not true. Okay, so the line is dotted because that is not a part of the solution. The points for this symbol or this symbol, the points on the line are not included in the solution. So that's why we draw a dotted line. It's just like the parentheses. It's excluding that line. That line tells you where everything starts, but it does not include the line. All right. So that's why we have a dashed line. For these, make it a different color. Less than or equal to or greater than or equal to points on the line are in the solution set. So we make it a solid line, okay? That is the difference. And then whether you're going towards positive or towards negative is based on the greater than or the less than symbol, okay? So I'll note that as well. So if you have this symbol or you have this symbol, you will be shading towards positive, okay? When I was learning this, they always said like shade up, but with X, there is no up, right? There's only left and right. So I like to say shading towards positive, okay? And then for these two, we are shading towards negative. Dashed lines, the line is not included. Solid line, the line is included. Okay, and let's just practice this. So the first step is actually setting it into slope intercept form so that we know what the line is. So we're going to graph it just like we graphed everything in the last unit. So we need y. I mean, it's not equals, right? But if it's in slope intercept form, it will help us to graph it easily. So consider the inequality x minus y is greater than 3. Graph it just like an equation, which means we start at the y-intercept and use the slope to build the line. And that's all we're gonna be practicing today. Finding the y-intercept, using the slope to build the line. So it'll be just like this, but instead of an equal sign, we have these, okay? So our first step here would be to set it equal to y. X minus y is greater than 3. I need to subtract x. Now I have negative y is greater than negative x plus 3. I put the x in front because I want it to look like this. Now I'm dividing by -1. Remember, when you divide by -1 in an inequality, we flip this sign. You must remember to do that. On my math lab, you have 20 questions and 5 of them, when I went through it, 5 of them had dividing by a negative as part of the work. So when you divide by a negative, you flip that sign so that it looks like this. Negative divided by a negative is a positive y. Negative divided by a negative is a positive x. But a positive divided by a negative is a -3. So we know our inequality is y is less than x minus 3. Okay, so that means our slope is 1. And our y-intercept is -3. So the way we use these is just like we use them in equations. If b is -3, that means it crosses y at 0, -3. 0x, -3y. So let's start there. 0 on x. This is the x-axis, this is the y-axis. 0 on x, -3 on y. The slope is 1, which is the same as 1 over 1. Rise over run. So up 1 over 1, up 1 over 1. Up to -2 over to 1, up to -1 over to 2. And it goes like that forever. You can also do a -1 over -1 because negative divided by a negative makes a positive. So we can go in the opposite direction. And that is our line. Now is when it changes, okay? Now you see that it's a less than. So they are not in the solution, so it's a dashed line. So as I make my line is a dashed line. It still goes on forever, so I can put those arrows. And now I need to decide it's y. So do I need to go towards positive y or towards negative y? Okay. It says y is less than. Less than means shade towards. Y is less than, shade towards negative y. Negative y is down, so I'm going to shade down. All of these points are in the solution. Y is less than x minus 3. Okay, and we can even test it. Nothing on the line is. Okay, so on the line we had 0, -3. Let's put 0 as our x and -3 as our y, just to test this point and see if the line is part of the solution set. Is greater than 3. 0 plus 3 is greater than 3, which becomes 3 is greater than 3. No, right? So that point is not part of the solution set. Let's try 5, -5. That should be part of the solution set. So x is 5, y is -5. It was 5 minus -5 is greater than 3. Minus a negative becomes a positive. So that is 5 plus 5 is greater than 3. 10 is greater than 3. So that is true. That one was true. This one was false. Right? And I'll just try one outside the shaded region, 0, 0. Okay? So for 0, 0, 0 minus 0 greater than 3. 0 greater than 3? No. Okay, so that's not part of the solution set. That's not part of the solution set. That is part of the solution set. So the line is dashed. The line is dashed, and we will shade the region below or toward -y. Okay. Let's go to the next one. X minus 4y is less than or equal to 4. X minus 4y less than or equal to 4. So I'll just set it equal to y first. Subtract x, -4y less than or equal to -x plus 4. Look, we've already got another one of these. Divide by a negative. Divide by -4, divide by -4, divide by -4. Okay. -4 divided by -4 is just a positive y. Flip the sign because we just divided by a negative. -x divided by -4 is a positive 1/4 because that was like 1x and a 4. 1/4 x minus 4 divided by -4 is a -1. Okay, so my line is y is greater than or equal to 1/4 x minus 1. -1, or sorry, my slope is 1/4. That means I go up 1, right 4. Up 1, right 4. Okay. My y-intercept is -1. So that means I start at 0, -1. 0 on the x, -1 on the y. I cross the y-intercept at -1. Now I go up 1/4, up 1/4, or I could go down 1 to the left 4. That's my line. My line is solid because there is the equal to sign, right? Points on the line are in the solution, so it can be a solid line. So I'm going to make a solid line through these 3 points. Draw the arrow to show it goes on forever. And then y is greater than or equal to. So for greater than, we're shading towards positive. Positive y. So positive y is up, so we're shading above the line, shading towards positive y. Okay. Another way to check your solution would be another way to check your solution would be to try Desmos and put in the equation. I'll put in the original equation, x minus 4y is, let's see, less than or equal to 4. All right, so I have a solid line through the points 0, -1, and 4, 0, and I have shaded above it. So that matches what I have here. Okay, a couple notes. In my math lab, use the line, and then there's an option. So we have the little line tool, and then there's an option for dashed and straight. So you can decide between those two. After you make the line, there's a paint bucket. It looks like that. It's a bucket with paint spilling out of it. There's a paint bucket tool, and you click anywhere in the region you want to be the shaded region, and it will color it. Okay. It will also like find a button, create a button that says edit coordinates ? And you can ignore that. After you paint it, you can click check answer. And even if you want to change and you're like, oh, I shaded up here, but now I want to shade down here, I would click the paint bucket and then press delete rather than try to change the coordinates. Changing the coordinates is a bit more confusing. So if you make a mistake with the paint bucket, click on the paint bucket, click delete, and then put the paint bucket back on the other side. Example 3, graph 3x plus 5y is less than or equal to -2. All right, I'm just going to write that again so I can solve for y. So really what this is, after you get used to the dash line and the coloring toward positive or toward negative, what it is it's just practicing graphing, okay? So we'll take away the 3x from that side. And now we have 5y less than or equal to -3x minus 2. I'm going to divide everything by 5. And what we end up with is y is less than or equal to -3/5 x minus 2/5. Okay. In my math lab, you won't have any fractions as your y-intercept. Those would be a little bit hard to plot, but we'll just give it a guess for this example. So our slope is -3/5. So that means I go down 3 to the right 5, or up 3 to the left 5, right? Rise over run. It's negative, so it's going to be going this way. And our y-intercept is -2/5, which means it crosses y at 0, -2/5. -2/5 is kind of above, it's like less than halfway between 0 and 1. So I'll just put it there. But I know the slope. So the slope is I'll go down 3. So I'm still a little bit between -3 and -4, not quite halfway. And then I go over 5. And that one's a whole number. So that's right on the line, but it's not on the line for y. It is a less than or equal to, so it's a solid line. It includes that line. And because it is less than, that means we go toward -y. And remember, positive, negative. It's harder to remember for x positive, negative. Okay, so color shade it. Shade it, y is less than, shade it towards -y. And you're done. It is a solid line. It is shaded towards -y. Next one, 3x is less than 15. There's only one step to get this to where I can graph it. There is no y, right? So I can't solve for y, I can only solve for x. 3x divided by 3 is x. 15 divided by 3 is 5. So our the final thing we have to graph is x is less than 5. Remember, if you see x, if there's only x, it crosses only the x-axis. If you see only y, it crosses only the y-axis. So what does that look like? If it was just a pen crossing the x-axis without crossing the y-axis, means it's up and down. It's vertical. Crossing the y-axis and never crossing the x-axis means it's horizontal. Okay. So x is less than 5. It is vertical, and x is less than 5. So I start at 5, right? Because if this was x equals 5, that means it would be 0, sorry, 5, 0, 5, -1. It would be every point on x, every every x value will equal 5. So now every x value is less than 5. So it's just like this, but it does not include 5. So we have to make it dashed. and it says x is less than 5. And this is why I like to say go towards negative or towards positive, because up and down, I don't know, right? So that's positive y, that's negative y. This is positive x, this is always negative x. So if it's x is less than 5, go towards the negative. So it's all of these points. It's my shaded region. And we can test it if you want. So here is the point 0. So the point 0, 0, x is 0, y is 0. I'm going to substitute it in. 0 is less than 5. True. There is no place for y value, but that's okay. It's still true, right? And if I did it over here at 6, 1, then it would be 6 is less than 5, and that is not true, right? And right on the line, that would be 5 is less than 5, so that's not true. So you can do it for a regular y equals, or you can do it for just an x value. Now we'll do it for just a y value. So y is always horizontal. This is y is less than 2. So y, where y is 2 will be our line, but our line is a less than, so it will be a dashed line. It will not include the line in its solution set. This is positive y, this is negative y. So it's less than 2, so it's going to, we're going to shade towards the negative y. It is a dashed line and it is shaded toward negative y. Let's do a Desmos. It's been a while. So we have y less than 2. Dash line shaded below the y or toward negative y. And we can even do the last one. The last one was x is less than 5. Dashed line, everything to the left is shaded. All right, now let's try this one. Y is less than or equal to 1/4 x minus 3. So you just graph this the way you would graph anything, any equation. Your slope is 1/4. That means we go up 1 to the right 1, 4 to the right 4, or down 1 to the left 4. Okay. Your b is -3, which means it crosses the y-axis at 0, -3. So let's start there. 0 on x, -3 on y, up 1 over 4, down 1 over 4. It has a less than or equal to, so it includes the line, so the line can be solid. And it says less than. Less than means toward, keep saying below, toward the negative y. Less than is towards negative, not towards positive. So I shade it. And I'm done. All right, example 7. Graph the intersection of x is less than or equal to 2 and y is greater than or equal to x plus 1. All right, let's start with x and 2. That means this line right here, right? It crosses x at 2 and it is a vertical line. So I'll draw that. Because of the equal sign, it's a solid line. So it'll look like that. and it says x is less than 2. So that means I want to shade this way. I'm shading I'm shading everything to the left of that line, but we're doing the intersection, so I'm not going to shade it immediately. I'm going to graph this one next. So that one, which I'll graph in a different color, is y is greater than or equal to x plus 1. That means my slope for y is greater than or equal to x plus 1. My slope is 1 over 1, which means I go up 1 to the right 1, or down 1 to the left 1 for my slope. And then my b, my y-intercept, is a positive 1. So I start at x0, y1. So x0, y1 is here. And then I'm going to go up, over. Okay? It's greater than or equal to, so that's also a solid line. So I'm going to make that one solid. And it says greater than. Greater than means above, right? So where they intersect means where I shade both of them. Okay? So I shade this one going this way. Right? I shade this one going this way the whole way over. And I shade this one going up. Where they intersect will not include where I'm not shading both of them. So I only want to shade where both of them would be shaded. So I'm going to stop shading when I get to the green line, because that doesn't include where both graphs are true. Okay? So I'll pick a point on here and I'll check it with both the graphs to make sure. So this would be x -5, y +5. Okay? So x is, so for this one, I'll just put it into this, right? -5 less than or equal to 2, true. 5 greater than or equal to -5 plus 1, also true. Because that would be 5 is greater than or equal to 4, -4. Okay. If I pick a point that was shaded by, this is an easy one, that was shaded only by purple and not by the green line, 0, 0. Then I have 0 is less than or equal to 2, so that's okay. But this one would be 0 is greater than or equal to 0 plus 1. And that is not true. So we want only the places where they're both true. Above this line, sorry, toward positive of this line, negative of this line. So we only colored that. One more. And this shouldn't be or, this should be and. So y is greater than or equal to -1. So y is -1. It's positive. Where y is -1, we'll make a line, a solid line. Greater than or equal to means above. Or sorry, towards positive y. And then our other line was, we have to solve x minus plus 2y less than or equal to 4. Subtract x, 2y less than or equal to -x plus 4. divide by 2. Y is less than or equal to -1/2 x plus 2. My m is -1/2. So that means I go down 1, right 1, or up 1, left 2. Sorry, I said 1, but I meant 2. And then our b is 2. So that means it crosses at 0, 2. So let me graph that. 0, 2. Okay. And then we go down 1 over 2. Down 1 over 2. Up 1 over 2 this way. Up 1 over 2. And you see that the slope is negative. It's less than or equal to, so it's a solid line again. And this one is less than, so it's going towards negative y. So where this one is positive and this one is negative is only this triangle right here. And before I let you go, I will just put that into Desmos so you can see what they would do with it. They had x plus 2y is less than or equal to 4. And then they had y greater than or equal to -1. So they put 2 different colors up, and then the darkest part is the part that is true for both. So that's your solution. But it does look like our solution. All right, and that is 2.7. It's some graphing practice and some inequality practice combined. All right, thank you all so much. Have a good day.